Hey, welcome back to your favorite fundamentals of college math class. We're going to take a look at volume and surface area. Here's our objectives today. Let's start out with some formulas for volume. You notice some rectangular solids here, right? So if you're finding the volume of something, in other words, like maybe how much water can it hold or whatever, you multiply the length times the width times the height. So for example, if this was, I don't know, 2 feet, this was 3 feet. This was 4 feet. And our volume would be 2 times 3 times 4. So we got 24 cubic feet of water is how much water we can put in this whole thing, right? 24 cubic feet, so on. So in other words, there's 24 of these little boxes in there, right? And here's another one. This one we've got 3 times 3 times 2, so you notice there's 18 of those um, cubic units. All right, so let's work this problem here. First, let's read it here. We're about to begin work on a swimming pool in your yard. First step is to have a hole dug. It's 90 feet long, 60 feet wide, and 6 feet deep. Let me kind of make a visual of this here. So I'm gonna dig this swimming pool, right? Definitely not an artist, but anyways, we got 90 feet. Here's our length. We got 60 feet wide. We got our height here. Looks like it's 6 feet. Okay. So you use a truck that can carry 10 cubic yards. Now this is alarming here. We're in cubic yards, but you notice our units here are in feet. So number one, we gotta change all these from feet to yards, right? So note cubic yards. So we need to convert. So for example, the length, which is 90 feet, there's for every 1 yard, there's 3 feet, right? So in other words, 90 times 1, we got, and the feet cancel here, we got 90 divided by 1 times 3, 3, and we're in yards. In other words, 30 yards, right? In other words, we're just dividing by 3, right? So let's convert that. That's 30 yards. 60, same thing. We got the width. We got 60 feet for every yard. There's 3 feet. Feet cancel. 60 times 1 over 1 times 3. We got 20 yards. 20 yards. And then finally 6 feet divided by 3. We got 2 yards. Okay, so now we can figure out our volume. So number 2, our volume is, because we can do it in cubic yards now, length times width times height. So we got 30 yards times 20 yards times 2 yards. So 30 times 20 times 2, we got 1,200 yards times yards times yards, cubic yards. There's our cubic yards. Yeah, that's how much dirt we gotta take out. It's 1,200 cubic yards worth. Number 3. Now notice, every time we use a truck, it can carry 10 cubic yards. So we got to figure out how many truckloads we're going to take, right? How many trips we got to take because it could take 10 cubic yards at a time. We got 1,200 cubic yards. So how many truckloads? Well, we have 1,200 cubic yards, and for every one truckload or one trip, there's one load per 10 cubic yards that it does. All right, so we got 1,200 divided by 10. 1,200 divided by 10 cubic yards divided by cubic yards. We got truckloads. 120 loads with the truck. We gotta do. So I'm running out of room here, but I think I can do number 4 right here. Now, so what's the cost, right? How much cost we have to haul all the dirt away? Well, the cost, we have 120 loads, 120 loads, and it's $35 per load. So 120 times 35, and we end up with, push that in, $4,200. Okay, so first in this one, we converted. Second, we found the volume. Third, divide by those 10 cubic yards so we know how many truckloads, and then figure out the cost by multiplying how many trips you got to take. In this case, it was 120 times 35 bucks per trip. And we get to 4,200. Let's just walk you through this. All right, how about volume for a pyramid? The volume of a pyramid is 1/3 the area of the base. So you'd have to figure, that's the capital B right there. Capital B is area of the base. Okay. Now, for the Luxor Hotel here in Las Vegas, you've got this square base. Okay, so the area of the base is just one side length by the other side length, right? And it has a square base length of 600 feet. So 600 feet, 600 feet. That's going to be our capital B. So it's the area of the square on the bottom. Okay. And then it also gives us, looks like the height is 350 feet. Okay, so number one, let's go ahead and figure out, because what we're trying to answer is this Luxor Hotel here in Las Vegas is based on the same shape as the Great Pyramid of Giza, which is 91 million cubic feet in volume. Is the Luxor Hotel, which is massive, if you've been down to that, at least it sure is to me, is it as big? Is it as big? Well, let's find out. Let's find the volume of the Luxor. Let's compare it to the actual Great Pyramid of Giza. I'm sorry. All right, area of the base. Area of the base is this square on the bottom, right? So 600 times 600 feet times another, I'm just going to do it like that, 600 feet. And then, so there's our area of the base, that's our capital B. And then our height is 350 feet. Okay. So this ends up being 600 times 600 times 350, all divided by 3. 42 million feet times feet times feet, cubic feet. There's the volume of the Luxor Hotel. The actual Great Pyramid of Giza, over 91 million cubic feet. So is it as big? Definitely not as big. Not even close, right? Not even half as big in terms of the volume. So that Great Pyramid of Giza, I can't imagine actually being there and actually seeing that. It must be massive. Here's another one with another building. The Transamerica Tower in San Francisco is a pyramid with another square base. It's 256 meters tall, so that's 256 meters. And the square base is 50, now we're working meters, 52 meters, 52 meters. So same thing on this. Area of the base, in this case just a square, so 52 meters, 52 meters, and then the height, 256 meters. And then you just multiply all that together and you get the 230,742 cubic meters. That's how big the volume is for that Transamerica Tower in San Francisco. All right, how about a right circular cylinder? So you've got pi r squared, which is that's the base because we got a circle, right? So it's pi r squared times its height. So area of the circle times the height, so pi r squared times height. Find the volume of this cylinder with a diameter. So all the way across is 20 yards, which means our radius is only 10 yards, half of that, right? And then it gives us the height, which is 9 yards. 9 yards. So our volume pi r squared h, we got pi, our radius is 10 yards squared, so 10 yards times 10 yards. Our height is 9 yards. So we got 10 times 10, 100, times 9, 900 pi square yards. Punch that in. Let's see. And our volume is 2827.43338. Anyways, let's keep going. Cubic yards, right? So let's say they said round it to the nearest whole unit. So to right there, I say, well, the 4, it's got to be 5 or above to bump that up. So round it to the nearest unit. In this case, would just be 2827. So approximately 2827, 2,827 cubic yards, approximately. All right, how about a cone? So here's our volume for a cone. We got a third pi r squared times the height. Third pi r squared times the height. And the volume of the sphere, 4/3 pi times the radius cubed. Okay, so that's for a cone and a sphere. So let's answer. I got a question here. Let's say you've got an ice cream cone. Oh, I love ice cream. 5 inches deep, has a radius of 1 inch. Spherical scoop of ice cream also has a radius of 1 inch. Okay, so this uh, radius of the cone is also 1 inch. If the ice cream melts, is it gonna overflow? That's the question, right? Will it overflow? Well, if it melts, so I need to know the volume of the ice cream, right? If I know how much ice cream I have, if I have more volume in the ice cream in this ball than I have room for it to melt into, then I have a problem and it overflows, right? So that's what we need to do is figure out the volume on those. Oh, come on. All right, so let's do the volume of the cone. Let's see how much room we have, how much volume we have. We know this radius is 1 inch on this cone right here. It's 1/3 pi. 1 inch is squared. Its height is 5 inches. So now I'm going to use my calculator. I'm going to go 1/3. I'm going to use my pi button. I got 1 times 1, still 1 square inches times the 5 square inches. Anyways, I punch all these in. So now I got 5 times 1 times pi. Divide that whole thing by 3. And I got the volume of the cone. So this is how much room I have for it to melt into is 5.235987756. No, I'll just leave it there for now. All right, how much ice cream do we have? So the volume of the sphere. How much ice cream do I have? So now we got 4/3 pi r cubed. 4/3 pi, our radius of this ball is 1 inch. So 1 times 1 times 1. So we got 4/3 times pi times 1 inch times 1 inch times 1 inch. Of course, that doesn't make a difference. But we end up with cubic inches. So there's the volume of the sphere. So if this melts, this is the ice cream. It's got to be less than the cone, right? Here's the volume of the cone, 5.23, blah, blah, blah. So is it going to overflow? No, I got less ice cream than I have room for it to go into. So it will not overflow. in this case. Okay. That should work for that. All right, surface area, surface area. So surface area for a three-dimensional figure, that's just saying how much paint, if I was to paint this cube, how much paint do I have? I would have to do that area right there. So that's a side squared. That's a side squared. On the back's a side squared. On the side's a side squared. On the top is a side square, and on the bottom is a side square. There's 6 of those sides, side squared, right? 6 of those planes, if you will, 6 of those sides that you would have to paint, right? So again, this is not volume, this is surface area. You add up all the areas together, right? So surface area for this rectangular solid would be the length times the width. So that's the bottom one. But there's 2 of them. There's one on the top. So there's 2 of those. And then length times the height. That's the right hand one and the left hand one. Length times the height, right? And oh, I'm sorry, that's the width. The ones I just colored was the width times the height. I'm sorry, the right and the left. And then finally the front and the back, that's the length times height, right? So you add up all those and so on. There it is for a circular cylinder. You got a pi r squared, you got another pi r squared on the bottom. And then if you think about, if you were to cut this and unravel it, right? Cut it and unravel it, what you would have is that's the length right here. That's this length right here. Well, what is that? That's the circumference. So that's 2 pi r, and then you've got it times this height right here. So it's 2 pi r times h. So that's like a rectangle. Again, if you were to cut that up right here and then unravel it, so that's how you can think about those two. You add them up. Okay. Let's just do the surface area for this rectangular solid. You've got the surface area, you've got length, width, height. So the surface area is 2 times the length times the width. So that's the bottom and the top, 2 of those. And then 2 length times height, and there's 2 of the width times height. So length, 8 yards, width, 5 yards. 2 times the length, 8 yards, and the height, 3 yards. Okay, so that one, this one, 8 yards times 3 yards, that's the front and the back. 2 of those, right? Let's do one more here. 2 times the width and the height. So the width times the height. So that's the left and the right. So 2 times 5 yards times 3 yards. All right, so we got, let's see, that ends up being what, 80 square yards. We got what, 48 square yards. Over here we got 30 square yards. So 80 plus 48 plus 30, 58 square yards is our surface area. This thing. Okay, so that's your surface area. Get the work right there for you. All right, thanks for listening. We'll see you guys soon.